Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at software engineering. For today's session, we will be looking at component based development. The learning objectives of this particular session include how to engineer the component based development software, and we will be looking at the overview of component based development and some of the standard packages associated with this component based development. If you look at the basic elements of component based development, mostly component based development are for reuse of the software systems. They buy and they do not want to develop. So, it is something like commercial off the shelf like COTS. So, we majorly shift our attention from programming to composing and from design to selection. So, what are the regular components that we tend to get without even implementing? Say we have got now various templates for developing the websites, so which are like component based development. Say from those eligible templates, we can select only those templates which are required and build on top of it. So we just have to reuse the code whatever that is available as template, and on top of it we will produce whatever wanted as a text. So this increases the speed of development and becomes cost efficient. So this could be some of the basic reasons why we wish to concentrate more on the component based development perspective. If you look at the origin of component based development, it is a component based software engineering and the approach to software development that is based on software reuse. So the entire thing that we wish to talk on component based development is towards the software reuse, and it emerged from the failure of object oriented development to support effective reuse. So as we looked at in the other session, where we wanted to skip on with object oriented design, where we wanted to give high level of abstraction, we wanted to provide aggregation, segregation, dependency and other relationships, but even though it has got some drawbacks and because of some of the failures that we have faced on object oriented development methodology, we wish to transfer ourselves with the component based development software. Components are more abstract than object classes and can be considered to be standalone service providers. So every component is supposed to be a standalone service provider, and this can, as I have already told you, these can reside on individual tiers of the architecture. At any specific instance of a service is required, we can call upon those services as a component and you can utilize directly. The definition of component based software engineering: component based software engineering is changing the way of software systems are developed. Component based software engineering embodies buy don't build philosophy. This component based software engineering shifts the emphasis from programming software to composing software systems. The implementation has given way to integration as a focus, as its foundation is the assumption that there is sufficient commonality in more large software systems to justify developing reusable components to exploit and satisfy the commonality. So anything that a person wishes to provide, say in case almost all the websites and other applications require an user ID and password, and it is needless to say the same user login credentials have to be coded again and again. So we can reuse those part of that components at least for any specific software that we wanted. On top of it, if we are about to provide additional security extensions like CAPTCHA or other image related security features, we can add on top of what is the existing credential that is available. So this we have seen already as a component. To give you a brief detail about the component, Unified Modeling Language specification defines component as a modular, deployable and replaceable part of a system that encapsulates implementation and exposes a set of interfaces. If you look at component from the object oriented perspective, a component contains set of collaborating classes. Anything that is trying to create an interface, collaborate, identify relationship becomes a component. From the conventional viewpoint, if you look at a component, it contains processing logic, the internal data structures that are required to implement the processing logic, and an interface that enables the component to be invoked and to be passed on to it. Some of the essentials of component based software engineering: independent components specified by their interfaces, component standards to facilitate component integration, middleware that support for component interoperability, and development process that are geared to reuse. As I have already told you, component is again like a service, can be utilized as a service by any provider or any user. See, these are independent components that has no link or connectivity with any other components that is associated in the entire application. Some of the design principles of this component based software engineering include: components are independent and has got no interfaces. Component implementations are purely hidden. Communication is through well defined interfaces. It contains a container, service provider for locating and getting component interfaces. Say for example, in this we have given a clear component which is about to implement, and we have got an interfaces which are connected to it. So these interfaces will be viewable from the user's point of view, and as a component, whatever coding or implementation that has to be developed, only those components are to be implemented, and it can also be reused. So everything will be put under one common container which contains all the data relating to it. Looking at the component models, a component model is a definition of standards for component implementation, documentation, and deployment. So this model gives a standard for not only the analysis and design phase, but then it is a standard for implementation, deployment, and documentation for all the rest of the processes. Component model specifies how interfaces should be defined and the elements that should be included in the interface definition. So previous session we have looked at user interface design. These components can in turn decide on how can we design on the interface, and where exactly the components are to be deployed can also be thought of at this component model level. Some of the very well known component models that we see in real world are Enterprise JavaBeans model, COM+, which is part of .NET framework, and Corba component model. If you look at object management group Corba, this has established a common object request broker architecture, which is again a component, and an object request broker provides service that enable reusable components to communicate with other components. Say by use of this ORB, that is object request broker, any number of objects can be reused to communicate with other components regardless of their location within a specific system. Just by calling, it can communicate with others. So that is what we have termed it as collaboration from the object oriented perspective of component model. Integration of Corba components without any modification within a system is assured if an interface definition language, say IDL, is created for every component. So we may have to create an individual interface that is called interface definition language, and after creation of this interface definition language, we can use any number of times within the system the same component. So objects within the client application request one or more services from the ORB server. Requests are made via an interface definition language or dynamically at runtime. So it can be made directly with an IDL or it can be through runtime. An interface repository contains all necessary information about the service request and response formats. So this interface will have all the information that are related to the services and its request, and it can again have the response in the same formats what is required. Not only that, this is part of Corba's platform, and if you look at Sun Java in the Beans we have component systems. In JavaBeans, we have component systems, which is portable, platform independent, component based software engineering infrastructure developed using Java. It encompasses a set of tools called Bean Development Kit, BDK, that allows developers to analyze how existing beans work, customize their behavior and appearance, establish mechanisms for coordination and communication, develop custom beans for specific application. So we can create our own bean for specific applications, and we can coordinate and try communicating, collaborating with other applications via this BDK. With the other platform like Microsoft .NET, a component object model is being developed, which provides a specification for using components produced by various vendors within a single application running under different Microsoft Windows operating system. So a simple application that is running on one specific system under Windows operating system can have this COM object model, that is component object model, which can provide a complete spec of all the components that is available under that operating system. So COM encompasses two components. One is on the COM interface, which is implemented using COM objects, a set of mechanisms for registering and passing messages between COM interfaces. Engineering of component based software. This should fulfill in the following aspects: identify the components which are candidates for implementation, qualify the interfaces of the components, adapting of the components to the architecture, updating of the components due to changes in the requirements. Say, as you might know, component based software exists as part of the design. This gives us a complete understanding of identifying what are the existing components that is already there with other sort of applications, and how to reuse on the current platform of application. So adaptability need to be checked, and we may have to update on the parts wherein we wanted to reuse on the software. Component based software engineering process has domain engineering, which has got certain library functions which are defined within every package, and component based development implementation function, which is already been built and included. If you look at this example, as far as domain engineering and component based development is concerned, we have two things which are quite often said here. One is on the component library. This component library has been extracting work on analysis, construction and dissemination phase, and component implementation is also working on the same phases, but then we will start from the analysis, we will create on a domain model, we will create an architecture diagram, we will have component qualification, which is directly updated on a repository of reusable components. Rather, if you look at the conventional domain engineering, it will have domain analysis, software architecture development, reusable component development and repository of reusable components. So it has a conventional flow where an analysis, design, implementation and testing and deployment is done on a sequential fashion, whereas with the component based development model we have the same sequential format, but then these components which have appropriate qualification can be used as reusable components at later instances. We have qualification component, we have component engineering, we have component composition, adaptation, which is given for testing for a specific application software, and any updates that is required can be updated only to those specific components for reuse. So this is an iterative process. To the same application software you need not redo or code, rather we can use that component and we can slightly alter on the implementation aspect of it. So from the diagram I am just trying to explain what the domain engineering means. Domain basically looks at identifying, constructing, cataloging and disseminate a set of software components. So that can be applied to existing and future software for a particular domain. most important functions are analysis, construction and dissemination. This is very common between domain engineering and component based software engineering. When we look at domain engineering analysis, we may have to define the domain that is to be investigated, representative sample of domain application in the domain where we can have business rules and we can imbibe some of the best practices. Business rules are dynamic rules that are to be generated as specific to the application, and we can have best practices that are previously defined and have its own standards. So, develop a model for that specific domain. This is for domain engineering construction, where we may have to select a function or an object. So, what is to be reused? Is the functionality needed for future implementations? What is the degree of reusability? So, sometimes we may have to assure on how much percentage of work is to be reused, or what is the degree of reusability or commonality of the features that this system will have from the earlier versions of the software. Is there a duplication of functions in the domain? Say, need not create multiple application softwares for the same purpose. For that specific reason, we can utilize those components which is already been in use, and we can directly make use of that instead of duplicating it into a different platform. Is the component hardware dependent? So, these are the questions that arise whenever we wanted to reuse on the software. So, I repeat those questions. Is the functionality needed for future implementations? What is the degree of reusability? By looking at the commonality or the features of the application software or the software that we tend to produce. Is there a duplication of functions in the domain that is available? Is the component hardware dependent? Is the design optimal for future implementations? We may have to at times check for the design also. Some of the design may not incorporate the components that we have produced for this structure. Say, from the beginning we have used a software which is for a desktop PC alone. Now that we have networked, so shifting the software from one machine to a network systems require reusability or optimality check, and checking from a network to a cloud based environment need again an optimality check. So, can a non reusable component be reparameterized? So, anything that you tend to see as a component that is not reusable, can it be reparameterized so that it can be reused at later instances for the same software that we are about to use it, such that it becomes reusable. It is useful to decompose or reparameterize a component for reuse. So, most of the times if the attributes or the parameters that are associated with any specific method or object, if it can be redefined or reparameterized so that it can be later on reused. So, we can construct a structural model. Domain engineering dissemination, this is part of deployment model. This has a library of components and has characterization for possible reuse. Looking to various aspects for it, like starting from product and technology make to a process to people. If you look at these three P's, this domain engineering dissemination looks at different perspectives. Say, from the product perspective, if you look at, we search for the requirement stability. We also look at concurrent development of software. We look for the memory constraints, application size, user interface complexity, programming languages, safety and reliability, lifetime requirements, product quality and product reliability. So, these are the major aspects with which product or technology is being evaluated. Whereas, for processes, we look at the process model, process conformance, project environment, schedule constraints, budget constraints and productivity. So, any of the specific component that you think it can be reused, it can be taken out directly from the previously existing software. And finally, we look for the people who are highly motivated for what sort of application, whether it could be for an education domain or an experiential or training domain, application domain, process, platform, language, and looking at the complete development team, we can directly incorporate the same team for development of different jobs, and we look for the productivity. So this component based development analyzes a particular application referring to the domain model. By use of this component based development, we can create an architectural design referring to the structural model. Component qualifications, adaptation and composition possible to engineer another component, and simultaneously you can go for testing of these components. If you look at the qualification of these components, it can be selected component effectively be reused, development and integration tools are required, runtime requirements, resources, speed, network protocol, service requirements like operating system interfaces and support of other components. Security features like access control and authentication protocols are part of component qualifications. Component adoption, assure that the component integrates easily in the architecture, consistent methods for resource management for all components, common activities, for example data management for all components, interfaces between components and the outside world have been developed in a consistent way, use component wrapping or custom component. So whatever it might be, if at all we wanted to integrate, we can use components. We wanted to use only the resources, we can invite the component. If at all we wanted to make the data management applicable, we can reuse on the component. Any component that need to be collaborated with the outside world, we can look at it as a component. Component composition, assembling of qualified, adapted and engineered components. So whatever that we have looked at till now from the qualification perspective, adaption perspective and engineered perspective, if all these three can be combined together, then it becomes a composition of components. So common architecture environment elements include data exchange model, where it is from the human to the software between the components among system resources. So whenever we wanted to make an automation tool, macros and scripts are part of these component based development. We can plan for data management as a structured storage, accessing heterogeneous data in a single data structure, and any underlying object model assures complete of interoperability. Some of the major problems that we may come across, say because of object oriented perspective, object oriented software engineering perspective, we came into the component based software engineering perspective. Now that component based software engineering can also come across some of the very decent problems like component trustworthiness. How a component with no available source code be trusted? So any component that we wish to take directly from some other thing, and if we use, how is that to be trusted, becomes a very common question, because shifting from one platform to the other platform, from one complete environment to the other environment is not that easy. So component certification, who will certify on the quality of the components? If at all, if it is to be reused, that needs to be properly standardized or it is to be certified. So when it comes to certification point of view, who will authorize on the component that this can be reused? Emergent property prediction, how can the emergent properties of a component composition be predicted? So if these components are available as libraries, when at what point in time these are needed can never be predicted, and sometimes if at all it is predicted, how better it is to be used as one of the component in the software that I am developing. And requirements trade-off, how do we trade off analysis between the features of the component with one with the other. So because of one of the failure that we have encountered in the year 1996, like Ariane launcher failure, this was purely because of the reuse of one component in the rocket. This Ariane launcher failure has happened in 1996. The first test flight Ariane 5 rocket ended in a disaster when the launcher went out of control for within 37 seconds after takeoff. So the problem that was mentioned as part of this launcher was due to the reused component from a previous version of a launcher. So from the previous version of a launcher, they have reused one of the component which made a failure. So, this inertial navigation system that got failed because assumptions made that when that component was developed did not hold for Ariane 5, but the functionality that failed in this component was not at all required in Ariane 5. So, this is one specific problem that we may have to look at. The functionality that the component which already had may not be required for the new component, for the new software at least. So, in that case, if we tend to produce this on top of it, that may also lead to a failure. So, that is one of the instances that we have quoted here which led to the failure, but then that functionality is not at all required. Some of the standard packages that we come across in the component based software engineering are SAP, Oracle, PeopleSoft, which are developed purely for specific business processes. Strong development in the last years shift from the custom made to the standard packages. So, we enable the working in a process by way of BPR, business process reengineering, and some of the best practices this business processes have built in started in the ERP environment, enterprise resource planning environment, where we had primary business process extended to many other environments. There seems to be large changes in methodology for implementation of software systems. Some of the remarks that we can mention as part of component based software engineering include component based software engineering and software packages change and implementation from programming to composing and from design to select. Integration of modules in existing architectures becomes more and more important rather than interfaces. Custom made around these standard applications, modules becomes complex and has to be integrated. Aspects with relation to what is leading, my requirement or the package move become different issues, important issues. Management and human factors stay the most aspect for success of implementation. In short, in this particular session, we have looked at what a component would mean. Then we have defined component based software engineering. We have looked again at the different elements of component based software engineering, and we have made a sketch on domain engineering comparing with the component based engineering. Within component domain engineering has been evaluated over different phases like analysis, implementation and deployment phase. Analysis, construction and deployment phase, whereas component based software engineering where we had the component qualification, component adaption and component composition. So, we have looked at one of the scenario where this component based has failed purely because of not want of functionality, and I have also mentioned you on a point of the various software packages which has components inbuilt, starting from SAP, Java, .NET and other models. Thank you.